Alright, I'm back, so let's get into this. Gotta get my bearings for a second. So we plotted the dates and the count, so we know that there's like 14,000 early on. That's like all the way back in 2011. Let me look at the data again. And then other than that, in this file, it looks like we just have some random features that we don't know anything about, and the card ID, which I'm assuming is going to match up with something from the other files. And from there, we can kind of merge that, cross-reference it. Let's look at those other files now then. Actually, let's look at the test version of the same thing to see if the distributions are the same. So I'll just copy and paste this. Test. Looks roughly the same, not too different. Looks like... Let's just look at the counts. Just to see the size, I'll just do the shape. So it does look like the test is a little bit smaller than the train, and obviously we've got 6 columns here and 5 here because they dropped the target in the test. So let's open one of these files and see what else is in there. I'll just type it in. How big is this file? Kind of big. Let's check it out. Authorized flag. I don't know what that means. I'm going to have to look that back up. Authorized flag. That isn't in there. Oh, this is just for the merchant CSV. Okay. We will skip that for now. Let's look at this authorized flag and see if it even matters. Let's do values just to see if they're all Y, because that's what it looks like. Not callable. Fair enough. Value, let's do value counts again. Yeah, they're all Y, so I guess they're all authorized. Which means let's just drop that. Dot drop. Axis equals 1, I think. And then we'll do in place equals true. That should do it. Yeah, there we go. New merchant transactions. City ID. Category. Looks like it's just yeses and nos again. Installments. I'd assume that's how many times you have to pay or something for whatever they're doing. Categories. More categories. What I am going to do is take all of these categories and then I'll just do a value counts on them just to see kind of what the distribution looks like. So I will do let's do categorical equals that category 1. We'll do city in there too because that's also categorical. Category 3. Merchant category. If I don't somehow make a typo across this entire thing, I'm going to be very impressed. Fully anticipating a typo. Category 2. State ID. Subsect. I think that's it. Maybe I could throw merchant ID in there too. I'd say probably not though. Let's keep that off for now. So here's all of our categoricals. I can already see that we've got some nans in there that we're going to have to deal with eventually. Let's see what value counts does. I'm not sure if it's going to be able to handle all of these columns. Yeah. How about we iterate through this? So for column in categorical merchant transactions column dot value counts. And then maybe let's plot that. That is putting them all on the same axis, which is not what we want. Let's just print it for now. And we'll print the column first too, so we can know what the heck we're looking at. Column city ID. So whatever city ID is 69, there's a bunch of them. Not sure if that's just a meme. And then there's a bunch of no's, some yeses for category 1, or N and Y. I'm assuming that's no and yes. And then there's ABC. Then there is merchant category. Category 2. State ID. I'm kind of interested to see what -1 means. Subsector ID. Alright, that's not probably the best way to look at that, but it's good enough for now. We'll have to revisit that at some point. Let's start off. Maybe we can merge it. So the left will be the train, the right will be the new merchant transactions on whatever it was, card ID or something like that. Let's just make another one below here. So it's, yeah, it's card ID. See what happens. Wow, first try. That typically does not work. Let's look at what the shape is of this now, though. Let's do a oh crap. Turned on insert. Merged df. Let's do merged train. And I think we might want to do that for test as well. Let's probably put that in as well. Yeah, okay. Let's do that for both, just so we don't have to do it later. Test should be it. Merged train df. Let's look at the shape to make sure we haven't epically. That is not what we want. Yeah, okay, so I am going to say, I think it's how equals left. Let's see what that does. What does that even mean? How many are in the new merchant? Maybe I'm thinking of this wrong. That should just be the subset of the left one. Let's try right just to see what happens, but I'm pretty sure that shouldn't be doing that. I'm assuming what it's doing is it's matching on the CIDs, and then there's multiple for each CID. Card ID, whatever it's called. Checking for duplicate keys. Validate one-to-one. We could do left only. Yeah, I figured that wouldn't work. The problem we have here is that this CID is mapping to multiple in the new merchant transactions, because you have to imagine that there's one customer who has made multiple transactions, or they're a merchant and they've made multiple sales or something like that. How should we deal with this? Because what you could do is you could capture multiple things from all the sales, but I'm assuming that we're going to have to do some sort of aggregate thing that I was seeing in a bunch of the other kernels. So it would be like you sum up the values, or you do something along those lines. I don't know if I really want to jump into that right away. Let's just take a peek at how they were doing that, though. They're making some elapsed time function, which is interesting. We might have to steal that at some point. PD get dummies. For anyone who doesn't know, that's basically creating some categoricals out of those. It's one hot encoding those, from what I understand. So instead of being like what we have is ABC, so they would turn that into 100, 010, 001. And that's just a nifty little way to do that using pandas and not needing to code that in manually or something. Let's see where they loaded in. This reduce mem usage thing is interesting too. So they loaded in the new merchant transactions and they parsed some dates. We might want to do that as well. Ag fun. Group by. Oh, interesting. So they're taking this and then they're grouping it by the card IDs, and then they're doing the sum and the mean. So what they're doing is, let's say let's open up this data frame. Let's see which of these makes sense. So let's say purchase amount. So if we're aggregating it by the CID, the card ID, then that would sum up how much, I'm assuming the customer has spent in total if you're doing the sum, and then the mean would tell you on average how much do they spend. That's what I'm assuming this means. Maybe we can try that. Let's do that. So they defined it as ag fun. So they're saying on I don't know why they did this portion. I'm going to just call this aggregate tours equals sum mean. Let's also throw in the max min just so we can. Maybe count. And maybe if we're feeling extra fancy, we will throw in, I was thinking of something and I lost it. Count, mean, standard deviation. I don't think that was the one I was thinking of, but we'll go with it. Group by, and then we'll do aggregators. I don't think this is going to work. Almost guaranteed, yeah. Group by. So I think we need to do it like they were doing it. Based on authorized flag? That doesn't make any sense to me though. So they're narrowing this down to a couple columns because they're just doing it on historical transactions. I don't know if I like that. I think I'm going to do that slightly differently. I'm going to do it based on the customer ID. Need to make sure what this is called though. I keep forgetting. Card ID. Interesting. I'm okay with that. Turned into a group by though. This always trips me up. I always forget. Oh, so we're grouping by card ID and then we're doing the aggregation. And they have all of this sorted out already. np.ptp. What does that do? Let's find out. Peak to peak. Make this a little bit bigger so everyone doesn't burn their eyes out. I don't entirely understand what that's doing, but oh well, we'll skip that for now. I do like the way they did this though, because it makes it so you can pretty quickly aggregate across many different things. We might have to borrow this and add some of our own flavor. And this is exactly what I had done. Sum, mean, max, min, standard deviation, and count. I threw in count. I don't know. Looking at this stuff makes me kind of think maybe we start looking at that, because I don't necessarily want to do all of this from scratch. Maybe I'll do a fork. I'll peek at the other ones first. I know that there was some public one that just did really well. This is interesting. It doesn't look quite as clean as the other one, though. I'll just start with this one, and then we'll make modifications, and we'll see what this one did differently. So I'll just download that. Download. Starter. And we will, I'm going to go in here and just let this run all. And we'll see what happens with that and what we can do. Module not found, light GBM. I should have that installed. Let me see. I guess I don't. Wow, that was fast. Okay. Let's see if that works now. Okay, easy. Dang it. I'm gonna have to restructure this. Input. And let's just shove all of this in there. We'll just skip the data dictionary. We don't, wasn't very useful anyway. Alright, let's see if this, nope, file still not found. Oh, duh, I moved the kernels. Crap. Oh my god, what have I done? This, all in there. And these are gonna go into a kernels. Hopefully that works now. No. Input, blah, 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 blah. Gonna import os.list dir just to see where we are. That is not reflecting that change yet. How about a restart? Guess we'll start that again and kill this one. that one was a little bit wonky. Let's see if this will do that. There we go. That looks like it's going. This is taking a while. I think this is pulling in that big. Yeah, this is like 2 gigs or something. Yeah, 2.5. Okay. We'll give that a second then. I'm gonna let all of these run now. And we'll see what we get. The one thing that I was reading that some people were doing was they would take this down here, they're printing out the feature importances, and then they are putting in a blank feature basically, or a random feature, and then they're seeing how that stacks up among the other features, and then they're trying to determine, is this better than random noise? And so that'll give you the signal of whether or not that's a valid feature or not, because if you're getting the same thing as random noise, then obviously it's not particularly useful. Let's see how much memory this stuff is taking up. Not very much yet. We'll see how that changes by the end though, because I saw they had this reduce mem usage in there, so I don't know, maybe just on the kernels they didn't have enough space, or maybe they just thought it would save them some processing power. I don't know. I'd have to look more closely at this stuff eventually. While this is running, let's just do a quick read through and see exactly what they're doing. NumPy, Pandas, Matplotlib, Seaborn, LightGBM, sklearn. They're suppressing warnings. They pulled in time, sys, date time, Matplotlib again. I'll just delete this stuff. That's all redundant. Doesn't matter, but just for brevity. Mean squared error. So the metric we're actually using is root mean squared error, but I don't think sklearn actually has root mean squared error, so they're probably just doing this and then taking the square of it. This reduce memory. So if the column is numerical, because they pulled all of those out, then min and max. So they're reducing the data type to int if it's below the max and min of these values. I guess that's interesting. I don't really think it's all that necessary. But I guess that's cool. We'll keep that. New transactions, read CSV, parse the dates. We looked at this kind of already. So this is the new merchants, and this is the historical transactions. We'll have to peek into those eventually. Binarize the DF. So 4 column in authorized flag category 1. I don't really know why you would need to do that though, because it seemed to me like authorized flag was all yes. We'll have to peek at that in a second once this is all finished running. To me that seems unnecessary though. Maybe in the test set there's some unauthorized flags, but I'd have to explore that some more. So they do that for category 1 as well, which we have over here. This actually has some yeses and nos, so that makes more sense. Maybe it is different for the historical transactions, because we were just looking at the new transactions before. So in this function, they bring in the file path. They're just reading it normally, then they're doing first active month, and they're changing it to date time. That makes sense. I'm good with that. Elapsed time. So we talked about this. So they mark down the first time point, or actually the last time point, and then they are measuring the time until new, basically. So how old the transaction possibly was is probably what they're getting at. That's kind of just a guess. And they're just doing it by number of days. And then they're taking target out of the data frame, and then they're just deleting it from there so that there's no potential leaks, I guess, just to clean it out of there, make it a separate variable. Get dummies, we talked about this a little bit. That's the one hot encoding. Did it for the historical and the new transactions. They honestly probably could have done the same thing for this binarize up here. I haven't experimented with this when there's only one variable though. Then they use their reduce mem usage function. Then they did the aggregations. They split it based off of authorized flag. I don't really know what that's doing. I'm gonna have to dig into that a little bit. So this is changing the name of the columns. So on underscores, they're joining strip for call in auth mean columns values. Oh, okay. So they're redefining the columns, and they are joining them on underscores and then stripping out the white space. Is my assumption. Then they're splitting. Okay. So these are the authorized transactions that they're filtering, and then these are the historical. I find it kind of bizarre that they renamed it to be historical rather than unauthorized or something like that, but whatever, that works. So here's the authorized flag that they binarized. Card ID, that's normal. City ID, they haven't touched that yet. Category, those are all zeros. That's kind of bizarre. Is that what we did up here? Yeah, okay. Installments, I don't think we touched that yet. Merchant category ID. Month lag, haven't touched that yet. Purchase amount, state ID. So this is all the stuff we've actually touched. So they took the category and they split it into the dummy. So this is the 10000, and then here's category 3. So they're doing 100. So that's one individual categorical. So let's come back to that because I think this is probably close to done. Yep, just finishing feature importance. So we ran it for several folds, it looks like, actually. Yeah. Okay, so that's interesting. We'll have to come back to that. It's already finished, made a submission. So they're saying that the most important feature is the auth purchase date max, which seems bizarre to me. All of these are dates. Typically dates shouldn't bring you the most information. I'm interested to see what the generic features, feature 1 gives basically nothing. Let's look at these. So that anonymous feature they gave us, none of them look useful. Maybe we're doing something wrong with them. That would be my assumption, because feature 3 is truly useless in this scenario. Let's look back at this aggregation. All right, so they're plugging in history. They're plugging in the historical transactions. But they're not doing, oh, they're doing the authorized down there. Okay. They're taking all columns, I believe that is. No, they're taking all the rows, and then the purchase date is the column. I'd have to double check on that. Date time index, history purchase date as type. Looks like they're kind of just pulling the date out of there. We won't worry too much about that so far. We understand this bit. This is just the aggregations that they're doing. So when they're looking at those duplicate per card ID features, they'll just add them up. They'll take the mean and all of that stuff. I don't know if mean is a useful way to look at a categorical. That to me seems bizarre. To me, I would think count would probably be more useful. Let's look at what that does. Auth category 1 sum fairly important. It's probably early for us to be making alterations, but I think we should throw in counts in there. We'll keep with their style and do single quotes. And I will copy this throughout all of those. This is kind of I guess this actually makes sense now that I think about this, because this is going to tell you roughly the distribution of the category that they pick. So if we're looking at, let's say, women's fashion, men's fashion, whatever, any number of categories, what it's going to do is take the average of those zeros and ones, and then it will tell you roughly what column or what category they typically purchase from, which I guess makes sense. And I guess count would be redundant in a sense, because the mean is just a kind of normalized version of the count, because we know that the value going in is always going to be 1 or 0. Number of unique merchants is kind of an interesting metric, because that's telling you how many different people they bought stuff from. And then this is how many different category of merchants they bought stuff from. I think those are all good, actually. Month lag. I still don't really know what month lag does. I'm good with this, and then this is basically just saying, let's run that code over the historical transactions, and then we'll rename the columns, saying hist underscore, name the column, as long as it's not card ID, because we don't want to replace that or change that in any way, so we'll keep that as card ID. And so that's just making things like this, hist purchase date min. So it's telling you this is a historical feature, this is the original variable name, and then telling you what kind of aggregation we did on that. And they do that for both the historical and the authorized. And then they aggregate it by month. One thing I do think will likely come into play that I've seen in a lot of these competitions is sort of like user or merchant embeddings. So you can figure out which users are similar and which merchants are similar. So I haven't done this, so I don't know a ton about this, but what you do is you kind of make an embedding in some form. I don't know exactly how you would do that for this kind of stuff. I only really know of it in the context of word embeddings. But that's definitely something that we'll probably look into in the near future. The other one is probably Bayesian optimization of the parameters of this stuff, because these seem like they're just kind of arbitrarily set, and I can run some Bayesian optimization, and it'll find out which gives us the best generalization error, or minimum generalization error is probably the best way to say it. Yeah, I guess we'll just continue on looking at this code and seeing exactly what they did. So they grouped it by card ID and month lag. So they're kind of just saying group the transactions, and then based on how old they are is, I'm assuming, what they're trying to do. And then they are counting, summing, mean, min, max, standard deviation of the purchase amount and the number of installments. I can't imagine the installments is going to be that important, but I could be wrong. So they're aggregating it, renaming the columns, resetting the index, grouping by mean and standard or grouping by card ID, and then aggregating by mean and standard deviation, renaming again, resetting the index again. Interesting. So how are they going to merge that with final? Oh, so they just kept train, which had the original features, and then they plugged in all of the rest. And then they're dropping these because LightGBM isn't going to be able to handle those. So then they're doing some parameters. Like I said, we'll probably optimize these. So they're doing k-fold. So this is your, I guess I'll just run through k-fold for people not familiar with that. K-fold cross validation. Hopefully they'll have a good image of that. Yeah, so this works. Basically, you split the test set into a bunch of different parts. So in this, they're doing 10 folds. That's what the K is number of folds. So you could have 5-fold, 10-fold. You substitute K with however many folds you want to do. And so in this example, they're doing 10 folds. So what you do is you split it into 10 pieces, and then you take one chunk and you say, I'm going to set this aside and use this to measure my metrics and train on the rest. And then you just shuffle it, not shuffle it, but you take the next chunk and then you do the same thing where you will train on all of these and then you test on this, and then you keep doing that. So we're doing this 5 times. So we separate the data into 5 pieces, and then we will take 4 of those pieces and then measure accuracy basically on the last chunk, and then we'll iterate through and do all of the different combinations of that we can. So this is a nifty little thing where they're taking the sklearn k-fold, which we imported up here. Whoops. And they're saying, let's split it 5 times. Let's shovel the data before we do the splits. And they're setting the random state so that it's reproducible. If we run this code again, we'll get exactly the same thing. And then OOF, that's out of fold. So what they're doing is they're measuring how big the training set is, and then they're filling an array with zeros. And so this is when we're making predictions, we want somewhere to put those at the end so we can make an entire out of fold recreation. So as we're iterating through this, we make a prediction on this, then we make a prediction on this, and then this, all the way through all 10 folds, or in our case 5 folds. And then after we finish that, we can measure the out of fold accuracy in order to tell us how well we did. And what we get to do with that is we train on all of the data, and we also get to measure our accuracy on all of the data, which is super useful. That gives us a slightly better look rather than just doing one split, and then our metric that we're looking at might be relatively limited in that we are grading ourselves on a relatively small amount of data. They start the time, they make a feature importance data frame, and then they are iterating through this. So the interesting thing with this is you do folds.split, and then you pass in the things that you want to split. So in this case, it's train values, target values. And then they are also enumerating. So for anyone not familiar with enumerate, that's basically just giving you a counter when you're iterating through this stuff. So this, the folds is giving you your train indexes and your validation indexes. So they are plugging that in down here in order to select the training data that they want, that specific chunk. And then the fold here is just going to output a 0, 1, 2, 3, 4 in order to tell you which fold you're on, basically. And so they're preparing this into an LGB data set. They're telling it, this is our input features, here is our target, and then they're defining the categorical features. So for anyone who's not familiar, LightGBM has a very cool feature where it handles categorical features automatically, because they're not the way that a gradient boosted tree handles them by default is not particularly great, and it does some wizardry in the background that makes it handle them much better. If anyone has the time, I highly recommend reading the paper. I believe it's, I want to say it's like Fisher something method, light GBM categorical, light GBM categorical feature. Nope, not that. Categorical. Did I get it right? I'd be really surprised if I did. They're saying this is number 8. It is from someone with the last name Fisher. Interesting. We won't read that now, but it's very useful. So highly recommend looking into that if you're interested. They're telling how many to train, basically, how often to print it out, when to stop if it stops improving, And then they're logging all of this stuff. They're making predictions and putting it in the out of fold data frame that we made up here, or array. They're filling this up with the features, the feature importances, which fold it occurred on, and then they're concatenating them, and then they are making, I believe these are the final predictions for the test set, and they are adding them all up together and then dividing them by the number of splits. So let's look how this did. Valid ones RMSE 3682299, 3622709, 360904, 378, 362, and I think they had something to print the final score. Yeah. So they got 3.66745 on their CV, and let's look back at. So they ended up getting 3.709. So there's a relatively big gap between those two. And then they basically plotted all that out. They did some extra work in there, but I won't spend too much time on that. I think maybe it's time for some Bayesian optimization. Let's see if anyone already did that though. I'll give this a second to load. The only time they use the word Bayesian, huh? That's bizarre. Oh well. Looks like they used ridge. They didn't use any of that stuff. Let's oh my god, this is a ridiculous plot. Okay. Well, looks like we are on our own for that. But we can still pull this from someone else. Bayesian opt. I am going to basically copy and paste this and then evaluate it in the Jupyter notebook because that is too low contrast. There we go. Making the data set, stratified k-fold, doing the splits, making a parameter dictionary. Let's just, I'm gonna take this up here now and compare that to the default parameters they plugged in. So they're doing param, let's rename this just to make it consistent. Honestly, let's go the opposite direction. Params. I think that's it. Yeah, let's go with params now. Let's do that as -1. I'm assuming that's going to allow me to do as many as I want. So number leaves, min data in leaf. Let's plug that in there. Objective, regression. I don't know. I'm gonna leave that off for now. Max depth. We have that. Learning rate. Min child samples. Let's plug that in there. I have the worst knowledge of any of this stuff in light GBM. I basically just know how to do the Bayesian optimization on top of this because I've screwed with it a couple times. I don't truly know what exactly these features all do. I know the general concept of what's it called? Gradient boosted decision trees, but I haven't bothered really messing with all of this stuff. So we will give this some ranges now that we plugged in new values. 30. Let's go from 10 to 100 just to see. Those all seem good. Let's do 5 to 50. Let's do 0.1 to 95. Let's do 0.1 to 1. Let's do 0.01 to 1 on that one as well. This isn't going to work because, this is interesting. Folds. We'll have to redo this to be somewhere in there. Or we'll build this function around this other stuff. Let's start off by putting this above here. And then this is taking in a bunch of arguments it's not prepared for. So let's start with that. Number leaves, col sample, min data in leaf. So that's the third one. Yeah. Subsample, max depth, reg alpha, reg lambda, min split gain, min child weight, min samples. That's new. Feature fraction. Bagging frequency. Bagging fraction. Dang it. I need to put all of these in there as well. Okay. Let's paste this down as many times as we probably need. So we need min data in leaf. Min child samples equals min child samples. Feature, no, doesn't work. Fraction equals feature fraction. Bagging freak. Alright, that looks okay. This is going to need to be changed though. I don't know if I really want to plug all of this in. I need folds, that's for sure. Actually, let's take this entire thing and put it below, so some of this stuff is already defined. Actually, let's just put this all the way at the end, and we will take as we need. So we'll do, This is kind of already formatted how we need it, where it will output this. I just don't really need, I basically just need this stuff minus the feature importances. Let's just take this and see what we can do with this for now. This all seems okay. I'll remove that print statement. That's just gonna muddy things up. Classifier, LGB train, params, that'll work. Train data, validation set. Let's make this less verbose. We need that. We don't really need these. Do we need the predictions? We don't really need the predictions either. What we do need, though, is this. So let's replace this with that. And we should almost be ready. I'm interested to see if this works. We definitely don't want that anymore, actually. Invalid syntax subsample. Where do we even have that? Subsample. Oh. Missing a comma. Nope. Name error. Bayesian. Oh, we didn't import it. That makes sense. Import. Is that what we need? I think it is. From. Yep. There we go. Damn. Name params is not defined. Oh. Fair. Fair. I get it. Should be of type int. Okay, we're gonna have to go in here and clean some of these up. Min split gain. So that's fine as it is. Min child weight. Probably fine. Min child samples. Probably not fine. This is the one we got tripped up. Let's focus on that. Let's just make that an integer and see what that changes. Almost guaranteed that still fails, but bagging freak should be of type int. Maybe I don't understand entirely what bagging freak is. Let's look up what that is first. Because I would assume that a frequency is between 0 and 1. Default equals 0. Subsample is another word for it. Subsample freak. Perform bagging at every k iteration. To enable bagging, bagging fraction should be set to value smaller than 1. So I guess we can try. Let's go back a couple. So let's go back even further. They set it to 1. I guess let's go 1 to 20. And we'll do 0.99 so that never breaks. Or let's go 0 to that. And then let's make it an integer. Bagging freak. Let's see if that runs. That seemed to work. Let's make sure we still have this stuff. Okay. So the scores to beat 3.66745. I'm thinking this will probably be the end. What I'll do is I'll set these to some really high numbers, and then tomorrow after work we'll hop back into this and see what numbers it found and if it was able to improve that at all. And then after that we'll have to see, does that yield anything useful actually on the leaderboard. we'll let it go one whole go through the 5 splits, because I know sometimes once it gets there, if we're not returning this correctly, then it might end up having an issue. So we'll let that finish before I kill the stream. One, two, three, four. So that ended up getting 3.66936. So slightly worse, but it basically plugged in random values, so I'm impressed it did anything reasonable at all. So it looks like that's working. Only takes 3 minutes to go through. So I guess I will end the stream. But first I will up this to something ridiculous. Let's do some math here. So when I wake up tomorrow, I can see what it did. So if we do 50 points and it takes 3 minutes, and we divide that by 60, that's 2.5 hours of initialization. And then what if we set this to 200? Let's go ambitious. Let's do 500 times 3 divided by 60. That would be 25 hours. That's too much. Let's do 200 times 3 divided by 60. That would be 10 hours. We could do 200, I guess. Might be overkill, but I mean, I might as well. My computer's not going to be doing anything else. Alright, so I will set this to run, and then I will report back tomorrow.